Hey guys, welcome to episode 23 of the peer-to-peer network coding session. So at this one, we're going to work on implementing the open storage project into the social trading project. Specifically, we're going to allow users to define a storage container where they are going to store their social trading information. Okay. So we already use this for trading signals. Now we're going to extend it, and in this second iteration, we are working at the peer-to-peer network. We are also going to make this upgrade so that the social trading part um, also uses this. So let's jump into the code. First, we are going to start by configuring at my own profile a storage container, a GitHub storage container for let me fix this first because we don't need these numbers around. Okay, so let me add here a storage container. Okay, so here we have one storage container for my trading signals and another that I'm going to call my social trading data. That if you see, I already have this repository because the mechanism is already implemented, but without using we're already storing this at a repository. So if you check my account, you will see that I have my social trading data here. Yes, I do have it. Um, so what I'm going to do is check this out. Okay, I will need these properties. Okay, so the first thing to fix here. Um, okay, there are several things to fix. Because the thing that I was seeing is that this container doesn't have initial properties. And the problem is that this property depends on if it is a GitHub storage container or not. But we don't know unless we check the father. So I will make an upgrade to this. And I'm sorry that I'm going to diverge a little bit of our main task, but if I don't fix this now, it's going to get worse. So I'm going to upgrade this now and call it GitHub storage container so that I can put the specialized properties there, because I remember that I had the difficulty in having to know which is the parent node, just because I couldn't know exactly which was the type of node. So we will dive into this and solve all the problems on the way. So for this, I will need one coding workspace like this one, for example. Okay, so here storage container. Okay, what is super algo storage? What is this? So there are two places I see, or three places, here and here. But now I'm curious, what is this super algo storage? Where else does this appear? Ah, okay. Now I remember. Yeah, we were thinking about creating our own service of storage to allow people to store stuff. So, okay, okay, I get it. So, beyond these two places, we will have the open storage project schemas. Here we have the schemas. Okay, so so go into the schemas first. So what we used to call storage container, we're going to create a new file called storage or GitHub storage container. Okay, and we are going to have another one that we are going to call superalgos storage container. Okay, so this storage container here, I'm going to copy it here and rename with GitHub storage container. And it's only going to attach to GitHub storage. GitHub storage containers. Okay, quite simple. And then we are also going to have superalgos storage container, which will attach to superalgo storage, and here it's going to be called superalgo storage container. So I will leave this just to be able to no, I'm not going to leave this. We should delete this. Delete this guy. And at GitHub storage, we're going to add a GitHub storage container. GitHub storage containers. GitHub storage container. Okay. And at superalgo storage, we will add a superalgo storage container. Superalgo storage container, superalgo storage container, superalgo storage containers. Okay, so we created two different types, GitHub and superalgos, and pretty much that's it. We're going to correct the icons for this, which is open storage icons. So we will have, for one, it's going to be called GitHub storage container, and this one is going to be called superalgos storage container. Okay, awesome. Okay, so that fixes the nodes. Then we will need to remove this, delete this, go to the social trading bot that have this, okay, disconnect this guy, and save this stuff, copy it, delete this guy, save this profile, and refresh this page. Then we will add a GitHub storage container to which we are going to add these properties. Okay, and the bot, okay, this storage container reference storage container reference needs to reference both GitHub storage container and SuperAlgo's storage container. Okay, and now we have referenced it again, and we are at the same starting point. But now, still we need to change the code. But now I'm going to modify this guy, GitHub storage container, so that it has some initial value. Okay. So none of these guys have an initial value. So I'm going to look for foundations, schema, APP schema, and look to see if I can find something like this. Okay, so GitHub storage container, we will add the properties that we already have here, which is code name, code name, and two more, which are GitHub username and Git repository name. Okay, so we save. For the case of SuperAlgos, it's going to be code name, and maybe you can keep the concept of repository like that. Or maybe URL. I'm not sure that we are going to have a repository name. But with URL, it's enough. So with the URL, you will be able to find and fetch the information. Okay, cool. So now I refresh this again. And this used to have so if I add a new one, it will have the initial properties. Okay, Okay, so here is where we will need my social trading data. Okay, so this is going to be my social trading data. It's a repository where I'm going to store my social trading data. Here, my trading signals, and the way that we connect this to a social persona is just coming here, add a storage container reference, and this guy create a reference my social trading data, and that's it. So we save this, and we have all the definitions ready in order to implement open storage at social trading project. Okay, that's good, but we will need something else. Remember that there were certain pieces of code using this information. For example, here, load, load storage container, identify storage container of each profile and load them to memory. Now this is going to be GitHub storage container. Okay. Okay. And then we still don't have, but function containers memory map. And we're going to do the same with the second type of storage containers that are the superalgo storage container. Excellent. Okay, this solves this problem. Then we have here a task functions. We need to correct this because this is going to be GitHub storage container, but also superalgo storage container. Okay, so this solve also this problem, and there might be some other problem. For example, if I search for storage container, Okay, we have to check that nothing is broken. Okay, so this is okay. Open storage client. Okay, this looks fine to me. Well, this is what I was saying. We don't need to do this with the parent. Technically now, we can just ask for the storage container type, and if it is a GitHub storage container or a super algo storage container, then we are good. Then we have GitHub storage. GitHub storage is about saving the file, also loading the file. So we have this solved. If we have this, we are okay. Okay, so I think we are good. Then web app interface. Okay, this is the last thing we did. Okay, so what we are seeing here is that the bootstrap process we have, and this is running both at the network and at the client. We will have a map of storage containers by ID. Okay, this is important. Then we have the GitHub storage. This client is not useful for us because this is saying one file. This is about saving files of okay, this is the workflow for dealing with candles. Okay, so this is a mixture. This model receive a file to save, and it know which are the available storage for the social trading bot when we're running. So I will pick one of the available and try to save the file there, blah blah blah. But GitHub storage can save a file at GitHub. Okay, getting the getting the API key from the API secrets, which is good. And it loaded from the raw interface. Okay, so what are we going to do? First, I'm going to commit all these changes. This is an upgrade to open storage. We made a little upgrade to open storage project. Okay. Now that we have this upgraded, we gotta go and check out. Where are we? We gotta go and check out. Not this is the network, but here, the desktop. We have this web interface, web app interface. And the problem we were having was that when we receive an event, where was that? Was that the query? When we receive, we need to get the post text. Okay, and a post is a file at the storage. So for the so to get in the post text, we are going to store the open storage container ID of the user of every time we save. So we are talking about that the workflow starts here. When you have an event that is talking about a post, can be a new post, a reply. I'm not sure about a repost because a repost is without text. So probably a repost does not qualify, but a quote repost does qualify. So a repost is a special case where there is no text. I'm going to remove it. And if I remove it from here, then I remove it from here, and I remove it from here. But also, I will remove it from here and remove it from here. Because the repost doesn't need to be saved as a file, just the repost. Okay, so again, when we have this type of events, When we have this type of events, we undefine the text. The post text is eliminated since it is now at the user storage, and a hash of the content was generated, and that is what is going to the network now. Okay, so that means that we need two things here. Maybe say post at storage. Maybe what I do is instead of sending individual stuff, and also this commit message is not part of the problem of this here. So I'm going to reorganize this save at, at storage function. This is false. They may they the way okay, we're going to redo this. You're not going to write it locally anymore. So each social entity must have a storage container so that we can here use it to save a post content on it. Okay, okay, so each social entity must have a storage container so that we can use it to save each post content on it. So here, save post as storage, what we are going to receive is not all this stuff. I'm going to redo all this. We're going to send just the event message. Okay. And this is not going to be set here. And the commit message is not going to be calculated here because there is no and there's not going to be a commit message probably. Or maybe it is, I don't know. So the thing I know is that I'm going to move this inside here and The elimination of the text is going to be here. So everything is disarmed now. So in here, we're just going to send the message to event message. So we need to save the post message as storage container and remove and let's say adapt the message before sending it to the network node. Okay, so that's what we do. When this stuff arrives here, let's check out what we need to do. GitHub storage. This is what we need to use to save a file. So we will need an instance of this guy. So this is an utility function. And I bet there is something called GitHub storage that we can use to save the file. Okay. We will need something like this. So we put all of this there. But also we will need, so this is an utility. That means that it's already instantiated. Okay, it's instantiated. So I just need to do this save. Okay. Okay, so let's go deeper. Where does this available storage come from? me see. Okay, I would take this whole code and try to reuse it here because it seems that users might have more than one storage container and we need to save them at all of them for redundancy. Okay, so um, this save storage, we have the event message. Okay, event message. All the others are not really something we need. So file content is going to be the event message dot post text. Okay, we are not going to are we going to encrypt the posts? Why not? If we encrypt it, that means that you can store stuff that nobody's going to be able to see unless you have the password. And to have the password, you will have to follow the guy, and then you will retrieve the password from the Open Social Graph. But without an effort, the, the storage provider will not know what is in there. So I like the idea to be encrypted. It's going to have a penalty in performance wise, but I like it. So let's say that by default this is encrypted. So password, encrypted file content, file name. We are going to hash the file encrypted file content, the file path. We need a timestamp. So we probably need to copy even more of this. Okay, so it looks like we used to have this like this, and the actual content is here. So we will have our own header. The timestamp is what is going to. I'm not sure we need this because we already have a timestamp generated at the user interface. So probably what we will do is file content is this, the timestamp is this, timestamp. So there is no file. And probably there is no commit message either, because then we have a file path, a file ID. Why do we need a file ID? Okay, probably we don't need this. Hmm, hold on. We do need the we don't need the timestamp, because otherwise two posts with the same content will have the same hash. So we need this structure. The file we're going to save is going to have a timestamp plus the contents of the post. So if I post two things very quickly in the same minute with the same content, they are still going to have a different timestamp, because this goes to the millisecond. Okay, and because it's different, and also the timestamp we are going to use, we are going to generate it ourselves, because that is what is going to guarantee. That is what is going to guarantee that is unique. You cannot trust that it's coming from whatever with a valid timestamp. So this will remove this from here. Okay, so we got a timestamp. The file content, we need to upgrade it with this. Then we get a password. When encrypt the file content, we hash it and have the file name with the file path. With the timestamp, we get a file path with the file ID. I'm thinking that there's still a chance that two different users have the same hash if they write the same post exactly the same time, but that is almost impossible. Okay, so I don't know why I used to need the file ID for the other case, but I don't think we need it here. So we're going to save this file at all the storage containers defined. So at available storage, that is a node that we need to locate. Okay, we need to locate that node. Storing container reference. If this is true, then if container is GitHub storage container, then we do this: open storage, file name, file path, encrypted container, storage container. Okay, so on file save, what we're going to do is to modify the event message. Okay, here we modify the event message is going to continue its journey to the peer-to-peer network node. Okay, so what we need to do is this guy event message. Okay, the post text is deleted. Okay, so this event message dot timestamp, we are going to override this with our timestamp. Also, event message dot post password is going to have this password. The container ID to open this event message dot post container ID is going to be storage container ID. Okay. And finally, the post hash is going to be or let's say event message dot post file name is going to be the file name we have here. I'm mixing the timestamp of the message is okay, is the one where it originated. Okay, so this is going to be the post timestamp. That is the one that I need to recreate the path of the container. Okay, then I need the post file name. Then I need the post password and the post store container ID. Or maybe I can use the concept of file key. File key, maybe I can store just a file key there. Timestamp, file name, file ID. What is the file ID for? Okay, the file ID is useful because then I can because I save this file in different places, and once I already have it, I don't need to continue loading them. So that's the technique. File path, file ID. So essentially, what I'm saying is that even message dot file key the file key contains all the information needed later retrieve this post. Okay, it contains a timestamp, the file name, that is a hash, file ID, container ID, and the password. So one thing that we do not need is a commit message. And most likely we got a problem here, unless we make this as really asynchronic. This will await for this. So all this stuff get obsolete. It gets obsolete because essentially we are using a new mechanism to save the file using open storage container. So we have missing here a few things. One is getting the available storage object. Okay. So how do we get the available storage object? The message we have the origin, social persona, or social, okay, or social trading bot. So let social entity ID is equal is initially this, but it can be override by a social trading bot if it is the one sending this. Social session trading bot ID. So once we have this guy, then we need then we need social personas by ID. That so we need to do this. But this is only going to be available only if we are running the service. Okay, so it seems that we will have to load this. Okay, now we don't need all the social personas by ID. Or do we know it? Do we need it? No. At, at the network, we have all the nodes of all plugins that have been loaded not this one. Network globals memory. User profile by blockchain account. User profiles by ID. Peer-to-peer networks by ID. Storage containers by ID. Permission granted by user profile ID. Okay, we don't have all the nodes. We only have the ones that we specifically created a map for. And at the network, it seems that we don't have that. So we have these maps defined. Social personas, social trading profile ID, but this is loaded only mm, not as a bootstrapping process, but only when the service is loaded. The social graph service, which means it's loaded at the network node, but not at the client. So we'll have to fix that in order for this to work. In the meantime, we need this guy. So we will get the social entity by doing this. Assuming this map has something, which it doesn't. Okay, once we have the social persona or social whatever, then we can do the available storage. Okay, so if a social entity is undefined, this is going to need to be a promise. Okay. Um, cannot save post because social entity is undefined. Okay. Okay, so if available storage is undefined, cannot save post because it's undefined. Okay, then from here, um, prepare the content to be saved. Okay, this is what happened here. And then we're going to save this file at all of the storage containers well defined, which will enter into this part. So if in this situation we will resolve cannot say post because storage provider fail to save. Okay, so we are responding with and if we could, oh, this is not a resolve, this is reject. There's a problem to trying to save this in more than one place because this this resolve is going to resolve more than once. Okay, unless we have to track the promise status. So that if this is unresolved, then we resolve it. And we switch promise status to solve it. Reject and reject it. Okay. Okay. So this guarantees that with the first file correctly saved, we are going to resolve, and at the response, I'm not sure if we should send back this message because the message is an object and we modify the properties of that object, so it shouldn't be necessary. So the promise status will resolve, and it's going to be rejected or resolve it only once. Okay. So here we have a very clean way to return a promise. Here. In fact, we don't need to return the promise at the end. We can return the promise immediately and shorten this to just return promise, new promise, say post async. Okay, so the result of all this stuff needs to be evaluated. Okay, when we do this, we do a let response equal this, and if response, if if response dot result is not okay, then we're going to return the response to our caller. Otherwise, it will continue and eventually send the information to the peer-to-peer network. Okay? If we could not save the post using the open storage, then there is no point in sending this message to the peer-to-peer network. Okay? Wonderful. So it was a nice coding. We haven't finished yet. Um, we haven't finished yet. We still need the peer-to-peer social graph service to know that there is a file key property that needs to be expected. Okay? File key. So when we go to the node, to the network node, let's stop this. So we have even received the event, then goes into not events but event, and posting event. So what we are going to expect at posting event, new social persona post, So we will add here one more property that is going to be the file key. File key. File key will have all the information to retrieve a file associated to the event. Okay, so that's the initialize. Okay, so when we have a post, we're going to just add a post. And we're just going to add this object file key. Okay, that means that a post, that is something that is where is the post? Utilities, globals, social graph post. This guy file key undefined. Okay, so I need to remove signal. Take a note about that. Remove from post, yes, and from social trading. Okay. So what I'm saying is that I'm going to send the file, the timestamp, and the file key. File key. I'm going to remove it right now because I don't think that I'm going to need this. Okay, so this is done. So we got a file key. We got it stored in memory, okay? And it's part of the event. It came until the post itself. Okay, so what else? File key. Okay, so another thing that we need is when we return the posts at queries, include the file key. Okay, so let's check the events query. So an event might have a file key. Okay, so I guess that we have everything to be able to process the response of this. Okay. Um, what else is missing? What else is missing? Okay, what was missing is to move. Let me what we need is to move or to load the social entity maps also at the client. Okay, today that is, and okay, so the place we got is that the remember the service, the social graph service that we modify so that at its initialization it loads into memory a lot of stuff? Well, it looks like that we also need that stuff to be loaded at the client side. So it cannot be at that service only. It should be at a place where I can execute it from that service, but also there should be some kind of representation of that service here um, at the client side, because that should be the one loading this stuff in memory. And once we have it in memory, then we can have access to it essentially. Okay, so but we're going to do this at the next episode. It's going to take us one more session to reorganize that both at the server and at the client side. But once we have it, we will be able to code the retrieve of the information from the open storage. And then we are going to be able to test if a post is saved and then retrieved. Okay, so these are the three things that debug post is saved and then retrieve it from open storage. Okay, so putting the open storage to work is fun, but it takes a little bit of time. But once it's done, it's going to remove us the need for cloning this repository locally and having this method of saving locally and having this push to GitHub for every post. Okay, also it allows the user to set up whatever storage they want. Yeah, information is encrypted and so on and so forth. Okay, so I'm going to leave it here and see you at the next one. Bye.